Hello everyone and welcome to the MLOps workshop. In the previous video we walked through a quick model overview of the example model that we'll be using for the serving and containerization sections. It was the Iris model and we packaged it with MLflow. So the other video that should have been watched before this one is the introduction to Flask as well, because we'll be walking through serving our Iris model through a Flask API. Okay, so let's get started. As you saw in the video, I serialized or packaged my model to disk in my Google G Drive, so I've downloaded that to my local machine here. And this is what we have. So I have a Flask, Iris, MLflow directory here. The model directory here was what was the output from our mlflow.pyfunc.save. So this is our model package that I've put in this directory. So let's take a look what was saved. So we have here, expand this out, our Python model.pickle file. This isn't going to be human readable. This is our actual model here. Not the actual model. This is our model wrapper that's been serialized. And then here we can see this should look familiar, our MLflow model. This is specific to the MLflow framework. We briefly discussed in previous videos the concept of flavors. So we can see we have our Python function flavor and we have our artifacts here. If you remember, we saved two artifacts in the notebook overview where we had a label encoder for the Iris class names and we had our state dict from the PyTorch model that we used or that we trained on the Iris dataset. We can see that we also have an env, which is our conda.yaml file. So we defined that in the dictionary. If you look here, here's all of our dependencies for our model. So, and we can see we have this code directory. And what this is going to contain is our metadata.txt file that we created and our model itself. Remember when we separated this out from the notebook into its own individual model.py file. So again, we've walked through this once before, but I hope you can appreciate how awesome this is, just having everything for your model in one self-contained package. Everything, including our actual model class itself, the weights that were serialized out, as well as the environment, metadata, any kind of pre-processing data artifacts like if it's tokenizers for NLP or label encoders for categorical data. It's all in just one central location. Okay, so to get started, we have our conda.yaml file, and we need to run conda env create -- file, and we'll pass in the file model conda.yaml. So let's go ahead and run this and wait for our environment to get created. All right, so after we've created our conda environment, we can activate it. Also, once you're inside of a conda environment, in order to get out of it, you just type conda deactivate. So, if we look here in our conda.yaml file, the name of our conda environment is specified right here. So, conda activate MLV. And here we can see we're now in our conda environment. Great. So now that we know we have everything that we need for our model, let's take a look at the other two files here. So one, we have requirements. Here, this is where we'll specify the requirements for the API itself. Right now, all we really need is Flask and Pandas. So what you can do is pip install -r requirements. So this will just go loop through the requirements file and install everything in here that we need. And great. So now let's get to the main section for Flask, the app.py. So what do we have in here? We can see we're importing from Flask, Flask, request, and JSONify. We're also importing MLflow and .pyfunc, pandas, because as we defined or previously described, the input for our predict method should be a pandas data frame. It doesn't have to be with the way that we created the model, but like I said before, it's kind of best practices, and we'll import the JSON library. So, like I said, you should have already watched the Introduction to Flask course or video before this one. So I'll just quickly walk through some of these concepts. So here we're instantiating a Flask instance. Here's where we load in our model. So mlflow.pyfunc.load model. This should look familiar, right? This is the same command we used in the notebook in Google Colab. And we're just passing in the directory where our model lives. So right here. And we walked through, we have all of this extra data inside of this model directory. MLflow just knows exactly what to do with this directory structure. So this is literally all we have to call to load in our model, and it's ready for predictions. So we also, if you remember, we also saved this metadata file, and we're going to see why here in a minute. So if we look at codes, here's our metadata. So we can see the file path is model code metadata. And yeah, so this is where we're loading that in. We're just converting it to JSON, calling file.read. So here we have, we're defining two routes. One is going to be at the root directory, or the root endpoint at this API, and it's going to accept GET requests, and what we're going to return is the metadata. So let's go ahead and run Python app. This might take a second just because it's loading in all of the data artifacts in our model. So here we can see at the bottom, I've specified host 0.0.0.0, that's just localhost, and port 5000. Right now I just have debug true on, so if I change this and save it, the changes get propagated automatically. But if you're running this in production, you don't want to run in debug mode. So let's navigate to, all right, and here we can see we're at the root endpoint for port 5000, and we can see our metadata. So this is why I said it's kind of nice to package the metadata, at least some form of description or documentation towards the model when you package it. So since we have this metadata.txt, anybody in a real service, this isn't going to be localhost port 5000, it'll be www.myservice.com, for instance. And you can have standard convention for all machine learning models where the root endpoint accepts GET requests, and there we'll have a general description, some metadata, version numbers. You can even have Swagger documentation at this endpoint or another endpoint. It's a good idea to have some information readily available regarding the model. Okay, so now we have a /predict route, and this route accepts post methods. If there's any software engineers listening to this, you might know that this somewhat breaks the RESTful convention. Typically, if you've already watched the REST video, which I believe was released previous to this one, it just walks through how REST is a standard convention on how we should structure our APIs so that we know how to communicate with them. And a lot of times, if you want to receive something from an API, you send a GET request, but you can't really send JSON easily in a GET request. It's kind of messy. You have to deal with query parameters. So generally, for my predict methods that I create for APIs, I use a post request. So in here, we can see we're getting the request by calling request.getJSON. In the real world, we're going to be having all of this packaged up behind a Docker environment, and inside of Docker, any print statements will actually get logged to standard out. So this is, it's an acceptable form of logging, just using print statements. Just in this API, it can be considered bad practice if you're integrating your code with other people's code to leave print statements in, but this is okay for this purpose. So here we're creating an inference data frame from our request and the data key on that request. and we're calling pred equals model.predict. Right, so here's our model. This is, it's 2 lines essentially to interact with this model. We load it in, and we call predict on it by passing in the inference data frame. We're calling toList here because the model will return a NumPy array, and we can't really serialize that into JSON, so we're also going to be logging both the request and the response here. And then we're just going to return a JSONified prediction format. So let's go ahead and see what this looks like. You can hit this endpoint using multiple different methods, curl, if you want from the command line, but I typically like to use Postman. It's a much more user-friendly tool. So we can see localhost 5000/predict. We're sending a post request, we're passing in data, and here we're just passing in an array, an array of arrays, right? These can be thought of as the feature vectors that we're passing in. And yeah, so if we go ahead and click send, here we can see that the Setosa and Virginica classes were returned. And if we go to our model, we can see, we have in logging, we have request. Here's our data that was sent in, and we also have the response, Setosa and Virginica. And this was, this is where we just took a packaged model, loaded it in, and quickly started running predictions on it by serving it behind a Flask API. If we were actually going to be putting this into production in a enterprise style environment, you'd want to change a few things. So like I said, make sure that you're not in debug mode. And right now we're serving directly through Flask by calling app.run. Most of the time you would use a tool like gunicorn or uWizKey, and basically what you use is you create a Flask app just like this, and instead of calling app.run, you actually serve the Flask app through a tool like gunicorn. It's more enterprisey. It has a lot more options available to you. Like you can spin up multiple workers of this single app. You can define number of threads. You can set timeouts. And then if you want to go one step further, you can actually put that behind an Nginx server. I've done this in the past. Nginx is a great, battle-tested, proven tool for production environments. But for the most part, this is, if it's a proof of concept or just a project, this is a perfectly acceptable way of serving a model from an API, and try not to get too bogged down in the details. The main thing that I want you to take away from this is we can see how easy it is to interact with our model when we package it in the proper format, right? By being able to just call load model and then model.predict on that without any kind of model specific logic. We don't have to clone in our pre-processing steps. All of that's packaged in the model with like the label encoder. It's a really awesome, versatile way of interacting with models when we package them, using these approaches. So that was serving a model through Flask.